Hello everyone, this is Suresh Kumar, working as Assistant Professor, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In the previous lectures, we discussed about the types of the dams and different type of the dams and different criteria can be taken as the construction of the dams will be discussed in the previous lecture. Now today our class is regarding the forces acting on the gravity dams. What are the forces can be acted and selection type of the dam. So in the forces acting, before going to be entering the forces acting, we should have to be look some points regarding the selection site of the dam. The selection site of the dam, as we know very well, the construction of the dam should be governed by the following factors. The first one is suitable foundation is available. We know very well suitable foundation for the and economy for the length of the dam should be minimized as small as possible. Why? Because the construction cost will be reduced and also the strength will be also increases. So that is the just like that is the difference between Nagarjuna Sagar Dam and the Srisalam Dam. Nagarjuna Sagar Dam is the wide range, is lot of gates is there, but even the Srisalam Dam is constructed for the minimum area length will be there when compared with the Nagarjuna Sagar Dam. So why? Because depth will be the more. So that's we have to protect the water. So not only that, the water pressure will be decreases and not only that, so the construction cost will be also be decreases. So let us the same economy type also we have to be seen. The general bed level suitable site should be selected preferably higher than the reservoir level. It should be reduced to the height of the dam. And second one is the suitable site for the spillway. Suitable spillway can be provided, availability of the vicinity, and also the materials are required as per the construction as near the site is there. Why? Because the lead charges will be the lot of affected in the economy of the construction of the dam. So that's the value of the land properly submerged by the possible dam should be as low as possible. Next, the forces on the gravity dam. Let us see the forces on the gravity dam. The forces on the gravity dam. So here, the design of the dam, various forces can be acted for the construction for the safety of the purpose. So let us see one look regarding the what are the forces acting on the gravity dam. The first foremost one is equal to weight of the dam. Weight of the dam are we call as self weight. Self weight of the dam, the huge structure will be constructed. How have the self weight can be affected in the dam. Next, water pressure. Next, water pressure. So now the water pressure, how the for the construction of the huge dam, so the water, how the water pressure can be affected in the construction of the dam. So how the forces can be calculated. Let us see one by one. Next, uplift pressure. In the uplift pressure, what happens? So due to the force acting on the top level to bottom, it can be tilted. Chance may be chance of the tilted as the dam due to the force of the water. So that's why uplift pressure. This is called. It can be rotated from one point to the base will be toe or heel. So heel or toe. So this is the heel. The heel may be uplifted due to the water pressure. This is the toe. So that is the uplift pressure we have to be calculated. Next one is the wave pressure. So the remaining all are discussed in the one by one. So wave pressure, earthquake forces, silt pressure, and the ice pressure. Generally, these are the some forces acting on the gravity dam. Let us see one by one. Weight of the dam. So weight of the dam is nothing but the dam self weight of the dam is calculated by using the formula W is equal to gamma into volume, X into volume, gamma M into volume. So Ym is the specific weight of the dam's material. That is called self weight. So here what is meant by self weight? Self-weight nothing but is the dam which is constructed on one particular area. The self-weight will be acted like that. That is the self-weight. The concrete, huge type of the concrete structure will be the self-weight, which is stagnated at one position. So that's why we call as the self-weight of the dam. So another one is water pressure. So how the water pressure can be affected? See in the diagram, it can be shown clearly that the water pressure is the height of the water which is can be generally stored FRL, that is equal to full reservoir level. The full reservoir level will be here. So from PW water, PW is nothing but water pressure. So the base width of the effect will be act as H by 3 from the base, by 3 from the base, that is the H by 3. So based on the formula, the water pressure which is acted on the construction of the dam, the water pressure P is equal to half into gamma W into H square. So where gamma W is equal to specific weight of the material and is higher the water. So that is equal to water pressure. Next one is uplift pressure. So what is the uplift pressure? Due to the water pressure, the dam may be uplifted due to the force is acting on that face. So there may be chances for the uplifting of the pressure. How the affected in the uplifting? That is mainly it can be affected on the heel, and it may due to the force, and it may be tilted of the dam may be one direction in the direction due to the force of the water can be stagnated here. So how to calculate the uplift pressure? So uplift pressure can be constructed U is equal to, U means uplift pressure, half into gamma W into HB, where H is equal to height of the water, U is equal to uplift pressure, B is equal to base width of the dam, and it is equal to base width with H by 3. Base width can be acted as B by 3 from the base. That is the B is the base width of the dam. By using the formula U is equal to 1 by 2 gamma W into H into B. So this is, by using this formula, you have to be calculated the dams will be constructed uplift pressure. So this is the uplift pressure is the main important for the to safety of the purpose of the dam. Next, wave pressure. So how the wave pressure can be affected? Wave pressure is very important. How you have to see in the wave pressure. So let us see, this is the one dam. This is one dam constructed here. Let us see so this is the dam we have to be constructed here. The wave pressure. The wave pressure is nothing but, so due to the waves can be top level, due to the air, the water waves, due to water waves, it can be hit to the dam in the topmost level. So due to the hitting of the dam, the pressure will be acting at the top. So that's why we call it as the uplift. The wave pressure can be acted like that. Let us see that when wave pressure is always acted on the top. So due to the wave action of the water, due to the wave action of the water, which is bombarding at the top level of the dams. So by how to calculate the wave pressure? So that is equal to wave pressure proportion of the pressure subjected to the impact of the waves. The maximum wave pressure per unit width is equal to PV is equal to 2.4 gamma W into HB. By using this formula, you have to be find out where HW is equal to wave height. The wave height will be affected from this portion to this portion. So that is equal, we call it as HW. So this is called HW is the wave height of the dam. Next one is earthquake forces. As we discussed in the previously classes regarding the earthquake. So earthquake force is very important Dams are subjected to vibrating during the earthquake forces are affected of the both body of the dam and the water of the reservoir behind the dam. The vibration forces are function both intercity or and its duration. The most of the danger effect of the vibration perpendicular to the face of the dam. Most of it can be affected perpendicular to face of the dam. So this is very affected of the earthquake force. So as we discussed before going to be construction and geological reports will be taken in the consideration how the zone will be the particular area which zone it becomes previously is there any affected of the earthquake that such type of the area will not be suitable for the construction of the like huge structures of the dams. So that is the very important. That's why you have to take the history of the last 100 years or 150 years or 200 years maybe. Availability of the data will be taken and not only the floods. How much the floods will become the maximum floods or runoff will be affected on particular area is the take it as the construction while the dam. So next it will be also affected them. Why? Because if a small effect of the earthquake force will be the collapse all the dams. Most of the death will be produced due to the effect of the dam. So and this is very dangerous and it is very precautionary will be taken for the construction of the dam. Next one is body force. So let us see the body force. In the body force, how the forces will be affected. The body force acts horizontal at the center of the gravity. At the center of the body force can be affected at the center of the gravity. This is another portion which is the slant portion due to the production of the dam. So that's why it can be affected right in the center of the gravity. So how to calculate the body force of the is equal to gamma into alpha into W. So where alpha is the earthquake coefficient and W is the weight of the self-weight of the dam. It takes as 0.2 for the practical reasons can be taken as directly we will be consider and take it as 0.2 for the practical reasons. Next, water force. As we know very well, the water force, how the water force can be. Wave force is different and water force is different. Please remember, these two are the very different. In the previous we discussed about the wave force. And now we are going to be discussing about the water force. So let us see the water force and water vibration produces the force of the dam acting as the horizontally. So PEW is equal to 2 by 3 CE into alpha H square. So by using this formula, how the vibration of the forces, water force, due to water force of the vibration will be generated inside the dam. So due to the dam inside, it can be take it as H is the value and PEW is equal to 2 by 3 into H. So PC is equal to another coefficient of 0.82 and H is the height of the H is equal to height of the water. So based on this applying the formula of water force can be calculated and coefficient of value will be taken directly in the 0.2 height as per the height of the water. So that is the formula for the calculating of the water force. These are the forces can be a consideration is the very important while the construction of the dam. Next to silt pressure. How the silt pressure, what is meant by silt pressure, how the silt pressure can be affected for this construction of the gravity dams. Let us see that one. In this gravity dam, in the silt deposit upstream side, which extent pressure on the dam is also known as the silt pressure. So the upstream side of the dam, which the extent pressure on the dam, which is the affected in the silt, it can be stagnated the silt here the bottom of the dam. So the pressure which is acting on the heel area, so we have to be considered as the silt of the ocean. So the PS is equal to 1 by 2 into Y SUB and HS square by K into A. What is this formula? How the silt pressure can be affected? Silt pressure is also one of the effect of the to destroy the dams inside to destroy the foundations. It can be affected in the especially in the foundations. So let us see in the how the silt pressure can be acts like that. So where PS is equal to silt pressure and V sub is equal to submerged density of the water and HS is equal to height of the silt deposit in the upstream side and K is equal to coefficient of active pressure. So active pressure, passive pressure will be studied in the geology and then here the upstream side, the downstream side. So let us see in the diagram clearly how the silt pressure can be taken. Here is the HS. HS is equal to here how the height of the silt deposited. Here see the how the it can be affected in the silt in the dam in bottom side. So that is equal to B here. B is equal to base width of the dam. By using this formula, PS is equal to 1 by 2 into YS of HS square by KA. So we have to be find the consideration of the silt pressure also. Next, ice pressure. So what is meant by ice pressure? How the ice pressure can be? In this in the ice pressure, not in our country, in the cold countries, there are western countries, some of the what happens, the topmost portion of the water can be becomes forms as ice portion. So that's why they are the suppose it is the dam, suppose this is the dam. So what happens in this top portion, the water can be becomes the ices in the cold countries. So what happens? The ices will be the forming and it can be tilted and can be bombarded simultaneously in the top portion of the dam. So in previously we are also have seen in the wave pressure is also affected in the top. But here what happens, the topmost portion of the dam will be affected due to ice. Icebergs can be forms here and it can be bombarded at the top portion. So the topmost portion can be affected. So these also can weaken the top portion of the dam. So that's why we have to take it as consideration as ice, especially the construction of the gravity dams in the cold countries. So how the value can be taken as, so the cold countries of ice can be maybe expanded the melt of the temperature variation to the melting pressure of the ice expand the pressure on the gravity dam. The force acting linearly along the length of the dam reservoir level. The magnitude of these values can be 250 to 1000 kilonewton per meter cube. Depends on the temperature variations can be taken the value. So as we know that the concrete gravity dams for the dimensions, check the safety, overturning, shear side, breaking capacity and no tension has been developed. Let us see in the diagram you can understand easily how the overturn, what we discussed in the previous. Let us see that one. So overturning. So let us see the overturning, how it can be affected. This is the effect of the, what is the difference between previous one? This is the stable and due to the effect of the force. So what happened, the overturning can be affected like that. The heel portion can be lifted upside. So that is the overturning checkup. Next, slowly it can be filled of the dam. Next, sliding. Or the sliding effect, let us see in the sliding effect. Here is the H is the height of the water can be affected and can be B is the base weight, as we know very well. So let us see it can be slowly can be moving one portion to another of the side of the portion, and sliding will be there. Let us see that one. The sliding will be done here. Let us see sliding and another sliding check. So bearing capacity of the check is also take it as consideration in the bottom. How the shear effect can be? It is a minimum. It is the maximum due to effect of the shear. So that the bearing capacity of the check of the portion will be effect of the dam. Next, by overturning is also toe can be affected clockwise and anti-clockwise direction. The crushing is very important. In the topmost portion, the crushing will be affected. So the general allowance of the concrete 300 kilonewtons per meter square value. So maximum value, P maximum, the pressure at the maximum, sigma V by B into 1 plus 6 E by B, and pressure at minimum is equal to V by B into 1 minus 6 Y. That is where sigma V is equal to total vertical force, E is equal to eccentricity, and base width of the B is equal to base width of the dam. Next, by developing the no tension has been developed, the maximum permissible stress of the tensile stresses for the concrete is equal to 500 kilonewton per meter square. In order to ensure that the development of the minimum and most of the can be 0, the maximum value of eccentricity that can be permitted on either side of these equal to the B by 6. On either side, it have to be B by 6. Now, sliding failures. This is the sum of the failures which we are going to be discussing. And sliding failure. What are the sliding failure? As seen in the previously what I had shown in the how the sliding will be affected. So the sliding will be the next horizontal force is equal to sigma. The force is greater than sigma mu into sigma v. The factor of safety against sliding is equal to sigma v under sigma h. The economical design shear force friction is equal to sigma v plus bq sigma h. Where mu is equal to Poisson's ratio, a general varies from 0.65 to 0.7, where B is equal to base weight and the Q is equal to average shear stress, and the poor rock is equal to 400 kilonewton per meter square, and for good rock is equal to 4000 kilonewton per meter square. This is the failure of the sliding of the dam. Next, what are the advantages of the gravity dam? The advantages of the gravity dam is the dam relatively more strong and durability, as we know. The maintenance cost will be the very less. So, the gravity dams can be constructed any height of can be provided as per the requirement and survey of the reports based on the functions, and the foundation availability of the foundation value is very affected. Next, the gravity dams are adapted for use as the overflow of the spillway. A gravity dam required the least maintenance, and the gravity dams are especially suited such area where it is likelihood of very heavy of the downpour, So that is equal to that is the advantages. Let us see the failure of gravity dam is not sudden. Failure dam is not sudden. So the slowing of the can be gravity dams. And also the another point is the gravity dam is the cheaper the long run. The benefit cost is always higher in the gravity dams. What are the disadvantages? That is the disadvantages is there nothing but the advantages is more. But let us see that the disadvantage initial cost will be the crores of rupees, thousands and lakhs of crores rupees can be invested on the gravity dam construction due to increasing the cost. It may be increasing day by day. Next, mechanized plants can be manufacturing and transporting concrete as required in the nearby, as we discussed, the availability of the materials and concrete availability will be have to be very needed. And the gravity dams are required to skill the labor can be constructed is required. So of course it may be acquired some other places also, but it is difficult to allow the subsequent height of the gravity dam. So these are some points will be 4 points of the disadvantages of the gravity dam. So next, elementary profile and the practical profile. So what is meant by elementary profile? Elementary profile is the dam, nothing but the cross section of the dam. You have to see subjected to only three forces: self weight and water pressure and the uplift pressure. Moreover, these three forces are many important remaining among all. So the elementary profile is has zero top width and no freeboard. Top width as with the elementary profile. That's why we call as the elementary profile. Okay, elementary profile. Topmost is equal to here 0. Next, right angle triangle is the most suitable section for the theoretical profile. Right angle. This is the, as I told, the right angle triangle is the most suitable section for the explaining in the practical elementary profile. So as shown in the figure, we will provide the maximum possibility of stabilizing the against of force and also overturning without causing any of the tension can be base. In case of base width, also B by 3 affected in the B by 3 from the dam and hence satisfied of the middle third rule. We call it as HB by 3 from the base is equal to middle third rule. Next, this is see in this diagram you can understand easily. So elementary profile of the dam, as I told, it can be the triangular portion. Why? Because it is no tension has been developed in the top. Why? Because it is the empty. The reservoir is empty. So small portion of the water can be affected based on the elementary profile B by B3 and B3 H by 3 from this height. So that is the shear. This is the shear diagram maximum how the shear can be affected. CWH where CW is the constant and this is the basic profile. R is the resultant force is acting on that. B is equal to base width B acting on that from this toe. From this heel B by 3 is also affected. So this is the main portion. Next, self weight of the dam. Let us see in the self weight of the dam 1 by 2 B into H into GW, where G is equal to specific gravity of the dam, which is generally taken as 2.4 for the concrete. Where specific weight is equal to 9.81. Generally, we are going to be considering 9.81 kilonewton per meter cube. The B and H base width of the height of the dam. The width B acts vertically downwards and B by 3 from the heel. Next, water pressure. How the water pressure can be P is equal to W into H in P into WH square. That is R gamma. Water pressure P is equal to W into small capital H square. So acts as the H by 3 from the base. That is equal to by using the formula you have to find the water pressure. Uplift pressure U is equal to B into CWH. This is another formula which are used for the calculating the uplift pressure. Where C is uplift pressure, intensity pressure. It indicates the uplift pressure. The edge of the uplift pressure can be X V by 3. Heel and upward direction is also shown in the figure. The base width, no tension has been developed. The reservoir is empty, but no tension has been developed means the reservoir is empty. So that's why conditions can be applied for the forces acting on the dam. The maximum value eccentricity is equal to B by 6 from the resultant force can be acted. So taking moment of the about the B, the value can be considered WB into minus U into B by 3 minus P into H by 3 is equal to 0. So by calculation of in B into HW into 1 by 2 CWH into B by 3 into 1 by 2 BW square into H by 3 is equal to 0. 1 by 2 into H by 3 W into GB square CB square minus H square is equal to 0. GB square CB square is H square is equal to 0. B is equal to H by under root G into C. So uplift pressure will be intensity is equal to C. We got the value B is equal to H by under root G minus 1. And in the uplift pressure, the intensity of the C is equal to, we get the B is equal to H by G. So next, base width of no sliding has been developed. The no sliding has been developed. the forces acting on the dam, the limiting value of the two forces will be equal and opposite. The limiting value is equal and opposite. So that is usually assumed that the sliding resistance of the only, thus sigma V is equal to sigma H. So where U is equal to coefficient of the friction. So by based on this formula, U is equal to W minus V is equal to P is equal to W minus U, of is equal to the pressure is acting on P is equal to W square as we discussed, and U into 1 by 2 VH W into 1 minus 2 BC into GW. After the calculation, B is equal to base width H by GU into G minus 3. The minimum base width as required, the elementary profile should be greater than values of the obtained from the equation of 1 and 2. This is equation 1 and previous one. This is equal to equation 1 and this one is the equation 2. Here is also equation 2. The minimum base width of the required elementary and should be values can be 1 and 2. Have to be find the calculation of the base width. So stresses, how the stresses can be developed, minimum stresses and maximum stresses. Here stresses can be elementary profile normally heel and toe value is equal to Pn equal to V by W, V by B, 1 plus or minus 6A by B. So here plus 1 is called the reservoir is full conditions, the maximum stresses will be reservoir is full, the maximum value that is equal to V by B into 1 plus 6E by B. The value will be taken as consideration and it is empty 1 minus 6E by B value can be applied. So based on the it can be changes according to the water storage capacity. The reservoir is empty conditions, reservoir is full condition. The maximum stresses and minimum stresses can be taken as in the consideration. So next practical profile of the gravity dam. In the previously I have discussed elementary profile. Here we have to discuss about the practical profile. In the practical profile of the elementary profile of the dam, to be adapted such some modifications has been done in the makeup advantages. In the elementary profile and practical profile is that main top width will be the here is equal to take it as consideration 0. Here the top width reservoir take it as some providing at the top for the road of the construction. So that is equal to practical profile will be practically can be used. So that's why some freeboard can be essentially where elementary profile has been not provided at the freeboard. The roadway can be generally. Second point is very important. In the roadway is provided in the top of the dam must necessity to kick the quite the top of the dam. Whereas the elementary profile does not provided any of the top. This is the main disadvantages, the difference between the elementary profile and the practical profile. And see that one, the road width can be compulsory provided the portion can be allowed for the in the dam. In addition to that, what happens? Addition to that, extra height provided in the freeboard due to the by advantages of the dam include some additional stresses in the dams will be also be section. So that is the one of the practical profile of the advantages. Some extra dam section to be provided in the base dam along the upstream side and such as the additional stresses can be provided to avoid the additional stresses. The amount of freeboard should be taken as 1.5 HW, where HW is equal to height of the wave meters between the through the crest. The minimum top width of the dam should be about 1/7 of the dam. See, let us see the example. So this is the simply forces acting on the gravity dam, and what are the forces? Elementary profile and practical profile has been discussed today's class. Thank you. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.